Okay, in this video, we're going to talk about factoring polynomials. There's two methods that I really use. You may have found other methods before, but the two methods we're going to look at for me is difference of two squares, how to factor that, and the AC method. So the first thing we're talking about is the difference of two squares. Now this is going to work when you have a polynomial that's of the form a squared minus b squared. Okay. The two squares means the a squared and the b squared. The difference part of that is the subtraction between those two expressions. And so when we're looking at something like x squared minus 4, what that is technically x squared minus 2 squared. Okay, so you need to be able to determine that it's the difference of two squares. Once you do that, it's a pretty simple process after that. When you factor a squared minus b squared, difference of two squares, it's going to equal a plus b times a minus b. Oop. So in the case that we are looking at right here with the x squared minus 4, that's going to end up being x minus 2 times x plus 2. Okay, so let's look at a different example. Go ahead and zoom that in some. And let's full screen that. All right, so for example, let's say we have 9x squared minus 49. What we have to determine is this sum term squared and is this sum term squared? We already know it's the difference. We got the minus sign between those two, so that's good to start with. But what is 9x squared? Can we express that as something squared? Well, that is 3x squared. All right? If you square the 3, you'll get 9. If you square the x, you get x squared. What about the 49? Is that something squared? Well, that is 7 squared. And so if we factor that, it should be the 3x minus 7 times the 3x plus 7. And there we go. Now you can always check these by expanding them out. You may have heard the term FOIL before, first, outer, inner, last. That's one way to do it. There's other ways to do it as well, but we will use FOIL for the ease of it. So first we're going to multiply the first two terms, the 3x times the 3x. And so that's going to give us 9x squared. Next, we're going to do the outer terms, which is going to be the 3x times the 7. And so that's going to give us, what, positive 21x. Next, we're going to do the inner term, which is the negative 7 times the 3x. So that's going to give us negative 21x. And lastly, we're going to do our last terms, which is negative 7 times positive 7, which is going to give us a negative 49. And see what happens with these difference of two squares is that these two terms in the middle are going to be the negation of each other. So it's going to be positive 21x and negative 21x. Those will cancel out when we add them, and so what we're left with is the 9x squared minus 49. And so this, which I wish I wouldn't have written here, but I can erase it real quick, is our factored form. All right, so next, now let's talk about the AC method. So the AC method is named after those two terms at the beginning of the polynomial, the A and the C. There. And that's why we call it that. Basically, what you do first is you find the value of AC, meaning that you multiply A and C together and determine what that value is. Now, what we're going to do is find a pair of integers whose product is AC. So when you multiply them together, you will get AC, but they add up. Their sum is B. So this means that we're looking for two values such that when you multiply them together, you get AC. When you add them, you get B. Then we're going to write that out as AX squared, which is what we already had, plus the little ax, which is one of those terms that we determined, the bx, which is one of the other numbers we determined, and then we're going to write plus the c. And then what we're going to do is factor the pairs of those. So we're going to factor this pair here, the ax squared plus ax, and the bx plus c. Okay? It's a little bit hard to understand when you're just talking about it, but I think once you do a couple of examples, it makes it pretty a little bit more easy to understand. So let's try some examples of this. There we go. Let's get rid of that. All right, so first example, we'll start off a little easy, and then we'll move from there. So the first example we'll look at is we want to factor x squared minus x minus 12. Okay, so the first thing that I like to determine is what is A, what is B, and what is C. So in this case, let's do it in different colors that way. A is just a 1, right? It's like 1x squared there. B is a negative 1, because it's kind of like negative 1x there. And C is going to be that negative 12. We retain the sign. So C is going to equal negative 12. So when we're following the AC method, it's good to identify them. Do you have to write them on the side? Not every time. If it works for you, do it. So what we're going to do is we're going to figure out what is A times C. Well, A is 1, C is negative 12, and so it's going to give us negative 12. So our AC is negative 12. Our B term, we already determined, is negative 1. So what we want to find is two terms such that they multiply, that's my multiplication symbol, to be negative 12, and they add to be negative 1. So we need to fill in the blanks and find different things. So we could try different numbers. Negative 12. Oh, well, I know. 6 and 2. Let's make one of them negative, right? But when we try that out, we don't get the negative 1. And it doesn't work. So let's clean that up. Boop, 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 boop. There we go. Let's try some different numbers. Well, this 12 and 1. Let's make the 12 negative. Why not? But when we add that up, we don't get negative 1 again. So let's, oh, I have closed my Jamboard. Let's open it back up. There we go. And let's erase these. All right. So let's try to serve different ones. Well, some other numbers that can multiply by 12. Well, it's 3, and there's 4. All right. But one of them has to be negative. But we can think about it in parts. Which one would need to be negative for us to get the negative 1? The 4 would have to be negative. 3 times negative 4 is going to give me negative 12. A 3 plus a negative 4 is going to give me a negative 1. And so these are the numbers that I am looking for. So what we're going to do now is we're going to rewrite our polynomial, but we're going to break up this term right here utilizing these terms, these numbers that we found. So let's try that. So we're going to still write the x squared for that first term, but the negative 1x, we're going to write that as plus 3x minus 4x, and then we're going to retain the c term, so negative 12. Notice that if you can combine these together, they are like terms, right? If we combine those together, what do we get? we get the negative 1x. So these two polynomials that we have here, they are equivalent to each other. We've just kind of moved stuff around a little bit. That's all we've done. Okay. So let's take this. What we're going to do now is we're going to factor this pair, and we're going to factor this pair. And so let's go to another page and do that. So what we had was x squared plus 3x minus 4x minus 12. We're going to look at this first pair right here. What can we factor out of these two terms? What do they have in common? This one has an x, this one has an x. So we're going to factor out an x, right? And so what we're going to end up with, and let's do this in a little bit different color, that way it shows up, is we're going to have the x we factored out, and what's going to be left over is an x and a positive 3. I factored an x out of those two. Now we need to look at this second pair here. What I want to do is see what I can factor out, but I also want to do it kind of with a little bit of foresight. I know what I want to end up with is an x plus 3. So I want to factor something out of that negative 4x minus 12, and I want to end up with x plus 3. What would make this, what can I divide that by such that I get a positive x? It's a negative 4, right? So what we're going to do is pull out a negative 4. We could pull out negative 4 from the 12. What would that leave us with? Positive 3. Okay. And so you kind of have some foresight in what you want to factor out from the second one. If you can't do it, you messed up, you need to go back and relook at maybe you picked the wrong terms, maybe you factored out the wrong thing here, but take a step back and see what went wrong along the way, because you should be able to get to here. All right, so now that I have an x plus 3 here, an x plus 3 here, I'm going to pull those, I'm going to factor those out of this term and this term. So we're going to pull out, give me the blue, there we go, an x plus 3. What's left over in this term here? Just an x. What's left over in this term here? A negative 4. And so my factored form is x plus 3 times x minus 4. That is a factored form of the x squared minus x minus 12. All right, let's try another one. Let's go, here we go. Let's look at, oh, there we go, a 2x squared minus x minus 6. So here, our a is 2, b is negative 1, c is negative 6. Right? Yep. So AC is going to be 2 times negative 6. I'm just going to start writing the times like that. And that's going to give us negative 12 once again. So we kind of end up with the same situation here. B is negative 1. So we want things that multiply to give us negative 12. And we want them to add to give us negative 1. Well, we already know the prime candidates for that. Negative 4 and 3. Negative 4 and 3. So negative 4 times 3 is going to be negative 12. And negative 4 plus 3 is going to be negative 1. So we're going to rewrite our quadratic, sorry, our polynomial. We're not quadratic yet. We're going to 2x squared. And we're going to replace the negative x with these terms here. So we're going to minus 4x plus 3x minus 6. And I always want to make this point. I always think people are going to ask me, no one ever does, but the order in which you put them here does not matter. Oh, I forgot my x and 3. But the order that you put them there does not matter. If you wrote plus 3x minus 4x, it's still fine. Sometimes they're a little bit easier to work if you write it in a certain order, but really doesn't matter. So I don't think it's worth putting thought into it. Just write them in whatever order you found them in. So let's rewrite that on another page. I need to remember what it was. 2x squared minus 4x plus 3x minus 6. So 2x squared minus 4x plus 3x. 6. And if you want, I mean, go back and try it with the different, swap the 4x and the 3x and see what you get. So now we're going to look at what can we factor out of these two. Okay, well, they both have a 2 in them, and they both have an x in them, so we're going to factor out a 2x. What's going to be left? Remaining x and negative 2. Now we're going to look at the second pair. Remember, I want to end up with the same thing here. So I want to end up with an x minus 2. What can I factor out of 3x minus 6 such that I end up with an x minus 2? Well, looks like it would be positive 3. That sign needs to come along with it. Okay? So now looking at this, I got x minus 2 here, x minus 2 here. We're going to take those, we're going to pull them out of there, and we're going to get x minus 2. What's left over? I like color, so that's why I'm changing color. We're left with a 2x, and we're left with a positive 3. So we're going to have a 2x plus 3. And so our factored form of that polynomial is x minus 2 times 2x plus 3. And let's try one more. Let's say I have x squared plus 9. A, in this situation, first off, they are squares, right? This is x squared plus 3 squared. But the problem is, that's not a difference. Not a difference of 2 squares. Can't use that on this one, okay? So that's a common error people make. That's kind of one of the reasons I throw this one in there. But in this case, A is 1. What is B? There's no B term, so B is actually 0 in this case. And our C is 9. And so AC is going to equal 1 times 9, which is 9. B is 0, so we need things that multiply to be 9 and add to be 0. Anything we can find. I mean, 9, we can only do 9 and 1. That's not going to have to be 0. No way. 3 and 3. That's not going to have to be. But there's a. Okay, well, what if one's negative? But the problem is that won't give me a positive 9. That will give me a negative 9. So no. So in this case, this is one of the ones that you cannot factor using the AC method. We will learn a method to solve these if they are equations, but this one is actually already factored. This is this prime factorization right here. So you can't factor this one anymore. All right. That's it.